Okay, hi lads, we're going to go through some harder sums today. So let's have a look at this first one. We have a right angle triangle, but within that right angle triangle, we have a small incline, and this is meant to be a flagpole on an incline. So let's try and work out some things about this. So we need to find to two decimal places F to G. F to G. So we need information about this triangle here. All I have is the fact that it's 52 degrees. So I either need to know that angle, or that side, or this side. So let's see what I can get from this one. So this is 52 degrees. So if I take 180 from it, I get 128 in here. If I add those two together, 128 plus 35, I get 163, and that give me 17 up here. Okay, now I can also do some more. If that's 35 and that's 5, that's 40. If that's 90, then 40 and 90. 40 plus 90 is 130, which means this angle up here is 50. And if that's 17, then this angle in here is 33. So now, if I know that's 33, that's 52, then this angle here is 95. So now look, I have loads of information before even doing the sum, just by using my basic rules. 3 angles in a triangle, two angles in a straight line. So that's all sorted. Now, let's try and find HF. So HF divided by sine of 35 should be equal to 6 divided by the sine of 17. So what am I going to do? HF is equal to 6 sine 35 over sine 17. So I'm going to keep everything to two decimal places to make it easier for myself. 11.77. So that's 11.77. Now I want to find FG. So FG divided by the sine of 33 degrees is equal to 11.77 divided by the sine of 95 degrees. Same thing again, FG is equal to 11.77 sine 33 divided by sine 95. And these are all in meters, so let's work this out. .43 meters. Right, brilliant. Now, let's look at our next question. So we've got ourselves a circle with a radius of OA. It's also the same radius there and the same radius there. And we've got a smaller circle with a radius R, which means that's also R there. Okay, and they want us to show that the areas, pi r squared, the ratio of the areas are in a ratio of k is to 1, where k is the number from the bigger one. So if I get the two answers, the ratio should be 1 is to something. Brilliant. So let's try and see, can we get the areas? So all I have to go on is that this is 60 degrees. This angle here is 60 degrees. But I do know for sure that that radius there will be the same as this radius here. Okay? Because, and how do I know this? Because these are tangents, and tangents have to be the same distance apart when they touch a circle from the same point. We did that in junior cert. So that would lead me to believe that if I can get them to be the same distance apart, that means those two angles must be 30 and 30. So let's take this small triangle here. It's got a 30 degree down here, we've got an R, and we've got something we don't know. Okay, so let's call this X. Okay, just for the sake of argument. Or no, let's not go with this one down here. Let's actually use this one in the middle, OD. Okay, OD. So the sine of 30 degrees has to be equal to R over OD. Sine of 30 degrees is a half r over OD. So no matter what, whatever r is, it's a multiple of 1. Whatever d is, OD is, it's a multiple of 2. So here we have it now. So we have the radius of the small one, that's pi, some multiple of 1 squared is to pi, some multiple of 2 plus r, so 2 plus 1 is 3. So OC, so that's going to be pi 1 squared is to pi 3 squared. Let's cancel the pi's. 1 is to 9, so that means k is 9. Okay, cool. Now, let's have a look. Ooh, look at this one. Look at this one. This one is beautiful. So, we have two diagonals and they cross in the middle of a cube. And we want to find the cosine of the angle in there. Okay, so let's break this down. We need to give this cube a number. You can use a real number if you want. It won't matter. But I'm just going to use an imaginary number. I'm just going to, not an imaginary number. I'm just going to use a variable x. So what I'm going to do is I'm going to see, can I create a triangle inside as if I was to cut this. So if I look at that, this side, this triangle I'm trying to do is a right angle triangle, because that's a right angle in there, and this side of it is x. So I need to figure out the diagonal of this. So let's look down in. There's x, 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 and I want the diagonal. So the diagonal is got by using Pythagoras. That squared plus that squared is equal to that squared. So that squared plus that squared, that's 2x squared. So it's the square root of 2x squared. That's what that is. So this is square root of 2x squared. Okay, now let's work out this one here. So this one here is going to be the square root of x squared plus square root of 2x squared squared. Now, we're going to tidy this up a bit. That's going to be square root of x squared. Now, squaring this root just gets rid of that root. So that's the square root of 3x squared. There we go. Now, how does that help us? Well, let's think. If I reverse this and look at the triangle going this way, then what you really have is a rectangle with two diagonals. This side is x. The side going across is root 2x squared. And this whole diagonal is root 3x squared. So if I want this angle in here, what I need to do is find out the distance from there to there. But of course, the distance from there to there in a rectangle is also the same distance from there to there, and there to there, and there to there. In other words, the diagonals bisect each other. They cut each other in half. So really, from there to there is, I'm going to actually tidy this up because I know that root 3x squared, if I separate them out, that's equal to root 3 multiplied by the root of x squared, and the root of x squared is just x. So I can actually write that in simpler as this, x root 3. So if this whole thing is x root 3, then this bit of it is half of it. It's x root 3 over 2. And so is this one, x root 3 over 2. So now let's do cosine rule on this. X squared is equal to a squared plus b squared minus 2b c cos of a. So let's rearrange this. X squared minus x root 3 over 2 squared plus x root 3 over 2 squared divided by minus 2 times x root 3 over 2 by x root 3 over 2, and that's equal to the cosine of a. Now, let's multiply everything out here. Don't be brave here. That's going to be x squared minus x squared, 3x squared over 4, plus the same thing again, over minus 2 times 3x squared over 4. And that's equal to the cos of a. Now I can see what's going to happen in here. That's going to be, I'll try and do this as quickly as possible. That's going to be x squared minus 6x squared divided by minus 6x squared over 4. And because I've got an x squared and everything, if I multiply top and bottom by 1 over x squared, it'll cancel everything and leave me with 1 minus 6 over 4 divided by minus 6 over 4, which is 1 minus 1.5 divided by minus 1.5, a third. So the cosine of the angle is a third. Okay? Right. We'll pause and come back in the next video.